Okay, we are continuing with scatter plots, and today we are going to look at what's called least squares regression, which is essentially a way of us going about calculating the equation for a line of best fit or a trend line for our data set. So a regression line is really just some sort of a trend line that summarizes the relationship between your variables, but we really should only use a regression line in settings where we really have a clear-cut explanatory and response variable. So that regression line is just going to be a line or an equation that describes how that response variable y changes as a result of modifications or changes in our explanatory variable. So here's an example that's going to be kind of pretty prevalent throughout the next couple of lessons, where we look at non-exercise activity and fat gain. So you have a scatter plot here, and then this red line is our regression line. So we can describe our scatter plot. We have a relatively strong negative linear association between non-exercise activity and fat gain. There are no apparent outliers in the data set. And then if we had the equation for this regression line, we could make predictions for essentially any value of non-exercise activity. We could plug it in for X and then find a predicted value for fat gain. So here's just an example without the equation, just using the graph and estimating. If you have about 800 non-exercise activity calories, tracing that up to the line and then back over to the y-axis, you can predict what that fat gain would be. So we should be able to interpret a regression line. And so when we do that, there are a few things that we need to keep in mind. One of them is that we are going to write our regression equation in slope-intercept form. We have a predicted value for y. So we write that using this symbol here, which we call y hat. And the hat on top denotes that it's a predicted value. So it is important that we put that hat there. A is your y-intercept, so that's your start value essentially, or interpreting when x is 0, what's predicted to happen with y, and it is important we talk about predictions. And then our slope, think about it as your rate of change. So as you change x by 1 unit, what are you predicting to happen with y? So here is an example that sometimes you see things similar to this for AP test questions, where you have an equation and then you're asked to interpret the slope and y-intercept. So here it's still that fat gain and non-exercise activity example, and they give you the y-intercept of 3.505. So essentially that's your start value. If there are 0 non-exercise activity calories, then we would predict a fat gain of 3.505 kilograms after the 8-week period, which is the second thing that's coming up here. The slope, and we can get that from our equation here, is the negative 0.00344. So that tells us that as we increase non-exercise activity by 1, so as we increase non-exercise activity by 1 calorie, we predict the fat gain to decrease by 0.00344 kilograms. Your book likes to write equations in this way, where instead of using a y hat and an x, they put the variables in here. And so something that you really should be doing is, if you do write it this way, y hat equals 3.505 minus 0.00344x, you should then say where y hat is the predicted fat gain and X is non-exercise activity calories. So it is something where if you're going to use the X and the Y, you need to define your variables. If you want to avoid having to write that out, you can put the variable names into your equation. So you can make predictions for y hat based on an x value. So here we have the equation. We want to make a prediction for 400 calories. So we could estimate from the graph. But now that we have the equation, we can plug 400 in for non-exercise activity and find predicted fat gain. And so here we have that to be 2.13 kilograms. And again, just putting that into context, we predict a fat gain of 2.13 kilograms when a person with non-exercise activity equals 400 calories. So you can find the regression equation on your calculator using the same thing that we did to find correlation. So that's StatCalc-LinReg. And so that does show up. It's that option 8. It gives you the A and the B, and then you plug in to write your equation. Just note that your calculator doesn't show you the hat, so you have to keep in mind that you need to put it there. If you use option 4, what your calculator is going to say is it's going to say LinReg, and then underneath it, it's going to say y equals ax plus b. So it switches the slope and the intercept variables, but then it's going to switch it below. It's going to say a equals negative 0.0034 and b equals 3.505. So as long as you pay attention to this form and put a and b in the right places, you can use either option 4 or option 8 on your calculator. But your book always talks about option 8 if you want to be consistent. We also had already previously looked at making a scatter plot on the calculator. You can put the regression line on top of the scatter plot by storing it into your regression equation. So here it's showing you on the calculator, you would do L1, L2, Y1, or you would put in the store regression equation, you would put a Y1 in there. And I'm going to walk you through that with my calculator in just a minute. You can also do these things on Stapplet, which I will show you momentarily as well. So if you don't have a graphing calculator, don't panic. You won't have to find these values by hand. But before I pull the calculator up, there are some things that we have to watch out for, and one of them is called extrapolation. So once you have the equation, you can plug any number in for x for a linear equation and solve for y. But we need to make sure that it actually makes sense. We call something extrapolating, or we say that we have extrapolation if you're using your regression model to make predictions that are very far outside of your original X values that you collected your data from. Because a lot of times they're not accurate. You come up with this model that might be really great for data that's in range with the X values from your data collection, but once you get outside of that range, we don't know if that model holds true anymore. So here is your homework assignment. And I'm going to go ahead and share my calculator with you here. Okay, so we are going to look at this same backpack weight and body weight example that we looked at previously on the calculator. So I'm going to pull that up here alongside of my calculator. Okay, so you want to, if you don't still have it in here from the other day, enter this data. So again, you would do that by hitting Stat and then Edit. Type all of the body weights into list 1 and all of the backpack weights into list 2. And again, the order is important. So if you mistakenly miss a value, you do need to go in and find exactly where it should be in the calculator. So once that's entered, you can run LinReg to get your y hat equation. So I can hit Stat, scroll over to Calc. Again, I can use option 4 or option 8. I'm going to use option 8 because it's consistent with your textbook. And then I tell my calculator list 1, list 2. I leave frequency list alone. And then store regression equation. I use this option if I want to put my line of best fit on top of my scatter plot. So I need to tell my calculator that I want to store that equation in Y1. So in order to do that, I hit my variables key. I scroll over to Y variables. And then I hit enter for function. And then I can hit enter again for Y1. So again, that was variables, y variables, function, y1. If you wanted to get the line of best fit on the calculator and you forgot how to do that and pull that y1 up, I can show you how to just type it in manually in a minute as well. So then we can go ahead and hit calculate. And this gives me my equation for my least squares regression line, or my line of best fit. So I would write my equation as y hat equals 16.26 plus 0.091x. I also have that correlation there that we had learned about previously. So now if I want to look at my scatter plot with the line on top of it, I have to make sure that I make a scatter plot. So I'm going to do second, y equals for that stat plot. Again, I just want that first one to be turned on. Everything else should be off. My type should be the scatter plot, which is this first one here, L1 and L2. And then once that's all set up, I can hit zoom 9 for my zoom stat. And then I see that line coming up on my scatter plot. If I couldn't remember how to get y1 when I was running linreg, I can manually type my equation in. So I could hit y equals, and then here I see my calculator stored my regression equation. If I didn't remember how to do that step, I could just type in 16.26 plus 0.091x, and your x key is right here with your x and your theta. And then I could go back to my graph and it's going to show me the line on the graph. The line on the graph is helpful because it can help us make predictions pretty quickly. So if I wanted to make a prediction about backpack weight for a 150-pound individual, I could do that by plugging 150 into my equation. I can also use my calculator. So I can hit, I want to calculate a value. I can hit second and then trace, and then I want to calculate a value. So I'm going to hit enter. It tells me x equals, well, I said I wanted to find the backpack weight of a 150-pound individual, or predicted backpack weight. I can hit enter. It puts my cursor on the line at that point, and it tells me my predicted backpack weight is 29.88 kilograms. When you're doing this on your calculator, you should get in the habit of, when you're done with a scatter plot, hit y equals and hit clear to get that equation out of there, because otherwise it's just going to keep graphing that equation in any other graph that you try to make until you go in and manually delete it. So if you go in and you manually clear it out, that's helpful. All right, so if you don't have a calculator, you can go to Statlet. And again, this is just where we were the other day. So under 2 quantitative variables, I've got my body weights, I've got my backpack weights. I can hit begin analysis. It shows me the scatter plot. I can hit calculate correlation to get that value. Right below that, I can say calculate least squares regression line, and then it gives me the equation. These other numbers that are here, n is how many observations you have, s is something that we'll deal with later, and then r squared also is something that we'll deal with later. You at this point don't need to change this to any other regression model, so just leave it as the least squares regression line, and you'll get your y-hat equation that way. And then if you scroll back up to your scatter plot, you can see that equation for the line of best fit on your graph.